Aw, no, sunburn. How did that happen? Oh, the sun, of course. What is the sun anyway?
Well, that's an interesting question. Hey there, Jimmy. I'm Amanda. I'm an astrophysicist. I'm here to answer your question.
You heard me? Have you been following me?
Maybe. Now let's go study the sun!
Whoa!
The sun is 150 million kilometers away from Earth. Astronomers call this distance 1 AU. Our sun is just a star, like any other star you see twinkling in the night sky. It's just that we have a name for our star, which is sun. The sun is also the largest body in our solar system. Its diameter is 1,392,000 kilometers.
But how big is that?
That's 110 times wider than the Earth. Like our planet, the sun has layers. At the center is the core, which sits at a temperature of around 13,600,000 degrees Celsius. Then we have the radiative zone, the convection zone, photosphere, and finally, chromosphere, which is the layer we see, which sits at 5,500 degrees. There is a layer outside of the photosphere called the corona, which gets hotter than the sun's surface, which sends off a solar wind.
Solar wind? What does that do?
When the particles from the wind reach Earth, the particles interact with the gas in Earth's atmosphere and produce a colorful aurora.
Awesome! How old is the sun?
The sun is about 4.5 billion years old, and although that's incredibly old for us, the sun still has another 4.5 billion years of life remaining.
So after that, will the sun go out?
It will, but not before going through some wild transformations. The sun is just a ball of superheated gases, in which 74% is hydrogen and 25% helium, and the remaining 1% is being made of other numerous gases. After 4.5 billion years, the hydrogen fuel will run out, causing the sun's core to collapse under its own gravity. The internal pressure caused by this event is so high that extreme temperatures occur, causing the remaining helium gas to ignite. This is called helium fusion. When this happens, the outer layers of the sun will cool down and then expand in size to change from its current state to what we call a red giant.
If the core collapses, why does the sun get bigger?
It's because of the heat at the core, Jimmy. Think of it as a balloon. When the middle or core of the balloon is cool, the balloon is small.
Then we add heat to the core and the balloon expands. The sun acts the same?
Exactly right, Jimmy.
Just how big will the sun get?
Big.
Really big?
Big enough that it might reach Earth. Once the helium gases run out, the core will no longer have enough gravitational force to hold the outer layers together. These outer layers will break off and form a nebula around the cooling core. This part of the sun's life is called the white dwarf star.
That all sounds amazing! I'm going home to learn everything I can about the sun.